All right, folks, here's an example of the problems that we're going to be working on in today's class. And if you notice, they're very similar to the problems that we did in last class. The only difference is this time I'm giving you, or we are giving you, either a set of equations. In one problem, we give you a table. In another problem, we actually give you a graph. And what you need to do is you need to write the slope-intercept form for the equations. You need to determine the number of solutions. What is the coordinate? Is it none or is it infinite? You need to fill in the table here and notice what we're looking for: the y-intercept of your first equation, the y-intercept of your second equation, the 0 or the x-intercept for the first equation, the 0 or the x-intercept for the second equation, and then finally the solution. And then over here, you're going to graph it just like you did last time. So you're going to figure out the best scale, where to put your x and y axis, and then you're going to make a graph. So let's work this out really quick. Since this is what you're given in standard form, everything that we like to do, and especially what the calculator likes, is slope-intercept form. So we need to get this into slope-intercept form. X minus 3y equals 9. And I'll write the other equation here. 5x plus 3y equals 15. So we want to solve for y. We want to get y by itself. So we want to subtract 1x. There's 1x here, so we want to subtract 1x from both sides of the equation. And then we need to simplify. Negative 3y equals negative 1x plus 9. We need to divide by 3 in order to get negative 3 in order to get y by itself. Divide by negative 3, divide by negative 3. Negative and a negative is a positive 1/3 x. Negative and a positive is a negative. 9 divided by 3 is 3. So our first equation is 1/3 x minus 3. The second equation, subtract 5x from both sides. In order to get 0, we need to bring everything down. 3y equals 15 minus 5x. We want to divide by 3. Divide by 3, divide by 3. That cancels. Now I have 1y equals 5 divided by 3. 15 divided by 3 is 5. Negative and a positive is negative. 5/3 x. So I'm going to rewrite the equation here, and I'm going to put it in mx plus b form. So I'm going to rewrite the order. Now, here's our slope-intercept form equations. And if you notice from our notes, we have different slope, different y-intercept. Therefore, there's going to be exactly one solution. Different slope, different y-intercept, there's going to be one solution. We're going to find the table, we're going to graph it on our calculator in just a moment so we can figure all of that out. So, I've got my handy-dandy calculator, and I've already typed in the equations here. So 1/3 x minus 3, 1/3 x minus 3, negative 5/3x plus 5. I hit graph, and this is what it looks like. Sorry, there's a little bit of glare on the screen, but you see the intersection point is down here. So our solution, let's find out what that point is. You can remember how to do this on your calculator. Second, calculate, and then we need to find the intersection point. So I'm just going to scroll down and hit enter. Now it asks me for the first curve of the first line, and it's the blue one. So it's the bottom one. I'll hit enter. The second one, it's highlighting the red one, or our second equation. It asked me to guess. It doesn't matter. Don't guess. Don't worry about it. Just hit enter one more time. And here's the intersection. When x is 4, y is negative 1 and 2/3. So I'm going to write that down. 4, negative 1, and 2/3. Sorry, that blank isn't very good. I'm actually going to write it bigger. Negative 1 and 2/3. So I can do the same thing here. I can write the solution. The solution is 4, negative 1 and 2/3. Negative 1 and 2/3. This is what your table will look like. The calculator, let's look at that second table. And here it is, 4 and negative 1 and 2/3, negative 1 and 2/3. Now there's a couple other points here that we need to find. We know that the y-intercept, if we go back to our graph, the y-intercepts are going to have a x value of 0 and a y value of 5. So here, so we know we got an x value of 0 and a y value of positive 5. For the y-intercept of equation 1, it's going to be 0, negative 3, and we won't worry about that, those two. Now we need to find the zeros, the y-intercepts, the x-intercepts. So there's one here, and then there's one way over here. So did anybody remember how to do that with the calculator? The calculator will tell you what the answer is. Second, calculate, and look, option number 2 is 0. The calculator will tell you what the answer is. So we need to find the left boundary. So we're working with the first equation, because it says first equation right here. So we need to go to the left, anywhere to the left. So here's anywhere to the left, this point. So I'm going to hit enter. And your calculator doesn't necessarily put these lines in there like this one does, but that's okay. So now I'm to the right boundary, and I'm going to hit enter. And it says guess. I don't care, don't guess, just hit enter. And there it is, it's 9, 0. So I'm going to write that in. For equation number 1 was 9, 0. I don't need that blank. Almost done, folks. And then let's look for the 0 of the other graph. So we're going to hit second calc. Going to hit 0. And no, I don't want a different. There it is. Now I'm on the second function. So all I did was tap up and down. I still need to get to the left of the x-intercept. So I'm going to hit enter. Now I need to get to the right. Now I'm to the right. Enter. Guess. Doesn't matter. There it is. 3, 0. 3, 0. And now, very quickly, I'm going to graph this. And if you take a look at how the really interesting point is the intersection is right down here in the 4th quadrant, but my y-intercept, one of my y-intercepts is positive. So what I'm going to do is I'm just going to use this straight edge. This is going to be my y-axis. And then I'm just going to use this straight edge here to draw in the y-axis. And I'm going to draw it in the middle. So that gives me some room above and some room below to put in my really interesting points, which are the intercepts. So I know I've got for equation 1, I've got a negative 3, so that's going to be 1, 2, 3, y-intercept of negative 3. Equation 1 is a 0 of 9, 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I do this kind of correctly, which we should see the intersection point kind of pop into place here once I graph the second line. Okay, so that's my first line. And then the second one is a y-intercept of 5. 1, 2, 3, 4, 5. There's 1. And then a x-intercept of 3, 0. 1, 2, 3. All right, so I'll put that in there. And I will graph that. Let's see if my graphing's any good. So remember we said it was 4, sorry, you can't see that. 4, negative 1.3. So 1, 2, 3, 4, 1 and a little bit. I'm slightly off. The intersection point needs to be right there at 4, negative 1 and 2/3. And that's what you need to do. There's a couple of problems where we give you standard form. Again, there's one problem where we give you a graph and you need to work backwards to get the rest of this material. And then finally, there's one problem where we give you a table. And if you remember, in order to make a table work, if I give you a table, you want to enter the table in the calculator using stat. So you click on stat, click on edit, type in your coordinates, and remember then you go to stat plot, and then you can plot everything and graph it and see what it looks like. And then to get the equations, if you remember what you do, you go stat, calculate, and you want to do a linear regression, number 4. So that's the tip of the day, is to remember how to do a linear regression using the stat button on your calculator.